This is Bird Project Team 2. My name is Joshua Moffett. This is Carson Downey, Jacob Hosel, and Greg List. Our project was to build a solution for our client, who's Elena Friedrich, and that was her PhD thesis, to do research on cavity nesting birds and the effects of light pollution on the birds. So our project was to replace a system that she was using previously, which is a trail camera mounted in the top of the bird box. But she was having problems with items such as corrupted data in the SD cards, as well as a very short battery life of like 2 to 3 days. And it was causing a lot of extra work for her and just making it a complete hassle. So she came to us, or came to our project leader, and suggested that this would be a capstone project. So this is what she had before here, with just like the trail camera on the top. And basically, this was the project, was to make something that fits around this box that she could use that would be better than what she had before. Basically our concept of operation and the way that we went about building this project was to use a single board computer with multiple sensors and a few extra sensors that she did not have before. The main ones were the ones that were different, other than the camera and audio, were a light sensor that is in the top here for recording ambient light, as well as a temperature thermometer that comes up through the bottom right here for capturing the temperature of the bird nest. And then also we have a brake beam sensor in the front here for triggering the camera that is here, as well as the microphone that is here, as well as also a PIR sensor inside for detecting motion if there's any activity inside the nest while they're just sitting in there. And then also all this information and sensors are controlled by a Raspberry Pi 3B Plus, and then all the information that is collected from all these sensors is stored in a USB flash drive. Here is some information on like Raspberry Pi. The camera we are using is a no IR, no infrared filter camera board V2, which is very compatible with the Raspberry Pi 3B Plus. And then we're also using just a mini USB microphone, which is also a standard thing used for the Raspberry Pi. Here are the other sensors that she didn't really have before that we added. Here you have the waterproof thermometer or temperature sensor. We have a digital light sensor that's in the top, and then we have the brake beam sensor. It's IR, and then also the motion sensor in the top as well. So all the operational components and everything is written in C++, except the light sensor, which is written in Python and then is accessed through a script. And then all the time tracking is kept offline through a different sensor that has its own battery that will last up to 5 years, because the Raspberry Pi does not come built in with any sort of timekeeping information or chips. So it will last 5 years, whether the Raspberry Pi is offline, online, or anything like that. It will continuously keep time for her to accurately analyze when birds were going in and out of the box, whether she has it on or off. So. And then going into the future, for her, the only thing we still need to do for her is make basically a bill of materials and an instruction set that she can use to build more of them and to implement them into all of her yards and basically all the cameras that she'll want to use for her birdhouses. And then build a different, well, just a slightly different function that it will start up on power up instead of accessing it manually like we have been trying to modify the code and everything like that. If we move something, we can see it on the screen, but the only thing we need to change is to make sure that it runs autonomously, which is just a slight change in the function. But all of our requirements so far have been met for what she has set, and then also some of the requirements that we have set. She has been very pleased with our project, and believe that she is very much looking forward to using it, and hopefully it makes her life a lot easier with her thesis statement and research.
Ready for a demo?
Yeah.
All right.
Okay, so for the demo of our bird box with the Raspberry Pi, Jacob here is going to put his finger into the box to trigger the PIR sensor, and on that screen you can see that the camera is now recording to a timestamped video file for about 10 seconds. The duration, the bit rates of audio and video, the actual resolution, it might be at 1080p, 720, 480. Those could all be configured by our client through a simple configuration file, including a duration of time to not record or be triggered. If you want to pull up the video, there, Jacob. And so the reason for why the video is so red is because the top of our bird box is off, and there's a lot of natural light, so it just bleeds through. That's that lack of an IR filter, which is useful for when we start recording at night and we trigger an IR LED so we can actually see in the dark.